Today we are going to see a problem from work energy power. Okay, this is from 2017 JEE. Let's go through the question first. Okay, a time dependent force F is equal to 60 is acting on a particle of mass 1 kg. Okay. If the particle starts from rest, the work done by the force during first 1 second will be what? This is a question. First, let's draw what is being given in the question. There is a mass here. Okay. There is a mass. Okay, and its mass is equal to 1 kg. Mass m 1 kg. A time dependent force is acting on that mass. Okay, that means a force is acting on it. Okay, there is a force acting on this mass. That force is time dependent. That means the magnitude of that force will vary with time. Right here it is 60. That means it's a linear. As time increases, it increases linearly. The force increases linearly. Okay, so a time dependent force F is there. F is equal to 60 is acting on a particle of mass m equal to 1 kg. Okay, and the particle starts from rest. What is the work done by the force during first 1 second? Okay, so let this be the initial position of the mass. Okay, and it is initial position means at t equal to time is 0 seconds. Okay, at this condition it is stated that the particle starts from rest. That means initial velocity must be 0, right? If the initial velocity is 0, what must be the kinetic energy? Initial kinetic energy must also be 0, right? After some time, after a time of 1 second, here in the question it is 1 second, the particle must have reached point 2. Okay, this is at time 1 second. After 1 second it reached here. Okay, and it's in motion, right? From here it moved to this new position, right? And it will continue to move. Right now this is the point at t equal to 1 second. Okay, at t equal to 1 second, this is our second position. At t equal to 1 second, it must have a velocity u2. Okay, and it must have a kinetic energy ke2 because it's moving. In the next second it might be somewhere here. Okay, but we are not bothered about that. Right now we are bothered only up to t equal to 1 second. Okay, so the question is, what is the work done by the force as it moved from 1 to 2? 1 is when t equal to 0 second, 2 is when t equal to 1 second. The question, what is the question here? Question is, what is the work transfer that happened as it moves from 1 to 2? Delta W. Okay, let's see. Here the work is given by the force. The force is being acted upon the mass. Okay, and that means energy is being given to, and the mass gets displaced, right? The mass gets displaced. That means there is an energy transfer, there is a work transfer. Okay, a work is being given to this body, given to this mass, and how much is that work? That is the question. Okay, we know as per energy conservation, energy can neither be created nor be destroyed, but can only be transferred from one form to another. Okay, so this force is applying energy to this. So initially the body had 0 kinetic energy. Okay, let's suppose this is the 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 mass is moving in a ground plane. Okay, it is moving along a horizontal surface, so we don't have to be bothered about the potential energy, right? So you can take potential energy at 1 is equal to 0 if we take this as the reference. Okay, similarly potential energy at 2 will be also 0. Okay, so what is the total energy change of the body? The total energy change delta E for the body is only the kinetic energy changes. That is K2 minus K1 is the change in energy of that body. So this delta E must be the work transfer happened, right? Is the work transfer here. Work transfer delta W. Okay, so work transfer delta W is equal to delta E, which is equal to Ke2 minus 0. That is work transfer is simply kinetic energy at 2. So we are asked to determine the work transfer, and that work transfer, the magnitude of that work transfer will be equal to the kinetic energy of the particle at position 2. Okay, so basically we need to determine kinetic energy of the particle at 2. That is the question. Okay, understanding the question is very important. Okay, so now let's proceed with whatever we know. Okay, it is given F is equal to 60, right? We know from second law, rate of change of momentum is force, right? Rate of change of momentum is P, represented by P. Rate of change of momentum is dP by dt. dP by dt must be equal to F. That means change in momentum dP must be equal to F dt. That is equal to, what is F? 60. 60 dt must be equal to dP, right? Change in momentum of the body at any instant t is 60 dt. So what is the total change in momentum as it moves from point 1 to state 1 to state 2? That must be integral 1 to 2 dP. That is integral 60 dt from 1 to 2, right? That means 6 t square by 2 from 1 to 2. Okay, that means delta P is equal to 3t square from 1 to 2. Okay, but what is T1? T1 is, you can see, T1 is 0. Okay, what is T2? T2 is equal to 1 second. 1, right? So substituting that value, we get delta P is equal to 3t square is equal to 3 into 1 square, that is 3 kilogram meter per second. This is the change in momentum as it moved from 1 to 2. Okay, and we know what is K2. K2 is equal to half m v2 square, right? Okay, that means we know delta P is nothing but momentum at 2 minus momentum at 1. Initial momentum must be 0. That means that because it was at rest, that means P1 is 0. So that means P2 is equal to 3, right? What is P2? P2 is mv2. So mv2 is 3, right? So kinetic energy at 2, and we know m is equal to what? M is equal to 1 kg. So what is v2? The velocity at 2 must be 3 meter per second. So kinetic energy at 2 must be half m v2 square, which is equal to half into what is m? 1 into what is v2 square? 9. That means 4.5 joule kinetic energy at 2. Okay, and our question, what was our question? Question was to determine delta w. Delta w, we know delta w is the work transfer is equal to ke2. So work transfer happened is equal to ke2 is equal to 4.5 joules. So that is the answer. You can see the option number D. So this is very simple, like it's everything is basic fundamental understanding of the question. You should understand the subject first. You should have a clear understanding of the subject. Then you should try to understand clearly what is being told in the question. Okay, then you start solving it. That's it. Okay, if you liked the content, please like, share and subscribe. If you have any doubts, please ask in the comment section. Thank you. See you with another question.